Hi, I'm working on a research that aims to classify the variety of rice paddies as well as measure its moisture content using audio analysis and deep learning. In order to collect data, I have here a data collector assembly that has a silo on which the rice paddies will be initially collected. I plan to drop the rice paddies onto some acoustic medium. In order to do that, the silo's opening would be controlled using a flap valve driven by a gear and pinion setup that I was initially planning to drive using a servo motor. However, on my recent tests, there were some jitters in the movements of the servo motor. Also, the noise on the movement of the servo motor is very much perceptible in the recordings. Hence, I now plan to use a unipolar stepper motor in order to drive the pinion in my data collector assembly. However, right now, the GPIO library I'm using, GPIO0, doesn't have any high-level stepper motor API. Hence, I decided to implement my own. To test, I have here connected on a Raspberry Pi 4 a 28BYJ48 unipolar stepper motor driven by a UL 2003 driver. Let's run example 1.py. Example 1.py will simply do a full clockwise rotation followed by a half counterclockwise rotation, however in a much more slower pace. With my code, we can actually specify the rotation parameters. For example, if you want the motor to run at about 1000 RPM, then we just specify 1000 on the command line as an argument. We can also set the step sequence and rotate the motor indefinitely. We can do that by setting the step sequence as we initialize or instantiate an object of stepper class. To perform indefinite clockwise rotation, we make use of the forward method, but in case you want a counterclockwise rotation, you just simply make use of the backward method. To this, let's run example 2.py with about 1000 RPM. By the way, I also included an example here, example 3, which we actually just perform a counterclockwise indefinite rotation. Okay? For more information, you can simply download my code in GitHub.